which happens to be quadratic equation video. So today we are going to be treating quadratic equation. I remain your tutor, Uzoma. Alright, so under quadratic equation, these are what we're going to be dealing with. Firstly, we are going to look at the definition and the proper introduction to quadratic equation. Then secondly, we are going to look at the methods we have for solving quadratic equation. And these methods include factorization method, completing the square method, formula method, and graphical method. But for today, this video, we are going to look at factorization method first. Maybe we'll compile other videos for other methods, but today on this video, we're going to be looking at factorization method. Alright, so before we start fully on quadratic equation, I would advise you pause this video right now, go get your pen and your paper so you can take some things down and also practice while we move on. And while you're at that, please hit the like button and subscribe. So let's go into it. A quadratic equation, I'm going to give us the definition now. A quadratic equation is any equation of degree 2. That is an equation that has 2 as the highest power of its variable, right? Now, the general form of a quadratic equation is this: ax squared plus bx plus c equal to 0. Where x now, we are seeing here, the x there now is the variable, while a, b, and c are constants. In other words, they are numbers, like numbers that has value, not variables. Okay, let's look at some equations and see if they are quadratic. Look at this first equation here: 2x squared plus 3x plus 1 equal to 0. Now, is this equation quadratic? Yes, it is, because as you can see over there now, x squared, that is x squared, the highest power of x, which is the variable here, is 2. Now look at the second equation: x raised to power 3 minus 6x squared plus 6 equal to 3x. Now you can see we have the same variable here being x, but the highest power of this variable, x, is not 2 again. It is now 3. Alright, it is 3. So this is not a quadratic equation, this is a cubic equation. Let's look at the third one, which is 7x squared plus 6x raised to power 3 equal to 0. This is also a cubic equation because we have 6x there raised to power 3. Alright, so moving further, let's consider, or rather let's observe these quadratic equations and compare them to the general form of a quadratic equation, which happens to be ax squared plus bx plus c equal to 0. Now the first quadratic equation we have here, as you can see, it's 2x squared plus 3x plus 1 equal to 0. Now if you compare this first quadratic equation to the general form of a quadratic equation, you observe that a, the position of a is taken by 2, so a is 2, right? And b is 3, c is 1, right? b is the number close to x, a is the number close to x squared. That's how you identify them. Now look at the second quadratic equation: 3x squared plus 5x equal to 0. Now here, a is 3, because we have 3 being close to x squared, right? And b is 5, we have 5 being close to x. But there is no c, so we can just assume c is equal to 0. Now to the third equation, third quadratic equation, we have a being 2, because it's 2 we have close to x squared, and b equal to 0. If you look at the equation properly, you will notice that there is no x, there is no number close to x. In fact, there is no x, so there is no b. But we have a number that is a constant, which is c, and that c now is negative 18. In all cases, a cannot be 0, because if a is 0, then there will exist no x squared. Okay, imagine for this first equation that 2 was 0, that is 0x squared, you have no x squared, and it is this x squared that makes an equation quadratic. Without this x squared, you don't have a quadratic equation. Alright, so let's go straight to factorization method of solving a quadratic equation. Now you see this method, it is not every quadratic equation that can be solved using this method, but let's just treat it anyways. If you meet a quadratic equation that cannot be factorized, you have to use other method. But let's just learn factorization method. Now for the purpose of this lesson, we are going to solve these 5 questions here. I'm going to use these 5 questions to explain this method for us. Alright, so let me use these 5 questions now. Starting with the first one, which happens to be 2x squared plus 3x plus 1 equal to 0. right? Let's factorize this quadratic equation. Now to factorize this quadratic equation. Alright, so before we factorize this equation, we know the value of A in this quadratic equation now is 2. The value of B is 3, and the value of C is 1, right? This is the first term, this is the second term, this is the third term, this is the middle term here. So this is what you do. These are the steps now in factorizing a quadratic equation. You multiply this third term here with the first term. So this is 1, this is 2. You multiply 2 and 1. 2 times 1, which is 2, right? 2. Then the middle term, being 3, we're going to place it here, 3. Now that we have gotten these 2 and this 3, now we got these 2. By multiplying the last term with the first term, which is 1 and 2, we have gotten 2. The middle term is 3. Now this next step, you look for two numbers that when you multiply them, it's going to give you 2. But when you add them together, it's going to give you 3. When you multiply, it gives you 2. When you sum up, it gives you 3. Now let's think of those two numbers. You see, whenever you meet a quadratic equation that when you arrive here, you cannot find the two numbers that you multiply to get this one and the two numbers you add, which are also the two numbers you add to get this one. If you cannot find those two numbers, then just know that that quadratic equation is not factorizable. So let's see if this quadratic equation is actually factorizable. 2 times 1 is 2, right? But 2 plus 1 is 3. So since we're able to see the two numbers that when we multiply will give you 2, right? And when we add them together, it's going to give you 3. Since we're able to find these two numbers, then this quadratic equation is factorizable. Now this is what I'm going to do with these two numbers I found, 2 and 1. I replace the middle term. Replace the middle term with these two numbers you have found, 2 and 1. So these are how we do the replacement. 2x squared plus, instead of writing this now, we're going to have this 2x plus 1x, which is the same as just x, right? So now you can see that nothing actually changed. When you replace this middle term here with these two terms, 2 and 1, nothing actually changed. Because 2x plus 1x is actually 3x. Nothing really changed. The equation is still the same, but it has taken us a step further. So we can now do this. Now that I have 2x squared plus 2x plus x plus 1 equal to 0, I now have 4 terms in this quadratic equation. 1, 2, 3, 4. So I'm going to factorize the first 2 terms and also factorize the other 2 terms now that there are 4. Okay, so let me start with these first 2 terms. You know how to factor out terms, right? I have 2 here. I also have 2 here, so I can factor out 2 from these 2 terms. I also have x here, and I have x here, so I can factor out x. So if I factor out 2 and x, let's see what will be in the bracket. I factor out 2 from this term, I factor out x from this term. But since this is x squared, there is going to be 1x left for this term here. You understand? Because x times x squared. So when I factor out x, there will be 1x left plus, when I factor out 2x from here, then I factor out 2x from here, now factoring out 2x from here, what will be left? Just 1, right? Because 2x times 1 now will give you that 2x. 2x times x, 2x squared, right? 2x times x, 2x squared, 2x times 1, just 2x. So now that I factor out these 2 first terms, let me factor out the other terms. That is x plus 1. I have x here, but I don't have x here. So I can't factor out x. But you see this x, I have 1x. This is just 1x. Remember, this was 2 and 1. Those two numbers we got 2 and 1. So this is 2x, this is 1x. So as you can see, I actually have 1 here. This is 1x. I also have 1 here. So I can factor out 1. And if you factor out 1, you'll be left with x and 1. Since 1 times x is x, right? 1 times 1 is 1. All equal to 0. Alright, so now we've gotten to this point. This is what we'll do next. This is the next step we take. We factorize again. These 2 terms outside the bracket, there are 2 terms outside brackets, right? This is 2x, it's outside this bracket, and this is 1 outside this bracket. So these 2 terms outside the bracket, you enclose them in a bracket. So this is 2x, then this is positive 1. I'm going to enclose them now in a bracket, right? These 2 terms that are outside, they are now in the bracket. Then these 2 that are in the bracket, now make sure that whenever you're factorizing, the 2 terms inside the brackets are the same. They must be the same. If not, something is wrong, maybe from somewhere something is wrong, but just make sure that whenever you're factorizing, the two terms in the bracket are the same. You have x plus 1, I also have x plus 1. So I'm going to take just 1x plus 1, right? Then equal to 0. Now that I've got to this point, I can then say that 2x plus 1 is equal to 0, right? And x plus 1 is also equal to 0, right? So now that I've got to this point, I can say 2x is equal to, if I send this positive 1 over this equal to sign to the other side, it's going to become negative 1, that is 0 minus 1, right? 2x is equal to 0 minus 1, right? So we're going to have 2x equal to minus 1. Then, now that I've gotten 2x equal to minus 1, I can get the value of x by dividing through with 2. So x is going to be equal to the negative half, which is negative 1 over 2. That's the first value for x. Now to get the second value for x, we look at this other bracket, x plus 1 equal to 0, x plus 1 equal to 0. So we're going to have x equal to 0. If you send this positive 1 over the equal to sign, it becomes negative 1, right? So this is x equal to 0 minus 1 minus 1. So we have two values for x, negative 1 over 2 and negative 1. Now listen, a quadratic equation has its highest power being 2. Since the highest power is 2 in quadratic equation, you are expected to get two answers for x, for the variable, right? When you have linear equation where the highest power there is 1, you get just one value for x. If you have cubic equation where the highest power is 3, you can get 3 answers for x, right? 3 values for x. But since this is quadratic, the highest power being 2, we usually get 2 answers for x. So that we have solved this first quadratic equation using factorization method. Let's move over. Alright, so for the second quadratic equation, we are going to factorize this quadratic equation. Let's factorize it. Now what do we do first? Look at the arrangement of the quadratic equation. You have x squared plus 7x equals to minus 10. This is looking unusual, right? So this is what we are going to do to rearrange it to look like the normal form of a quadratic equation. We are going to have x squared plus 7x. And this negative 10 we're having over there, we're going to bring it over the equal sign back to this left hand side, right? So when negative 10 crosses the equal to sign, it becomes positive 10. So equal to 0, since there is nothing left now. The negative 10 that was there, we brought it over, it became positive 10, so it's now equal to 0. Now this is the general form of the quadratic equation, which we all are familiar with. So now let's factorize this quadratic equation. As usual, you multiply the last 10 with the first 10. Now from the previous equation we factorized, we have 2 here. So we multiply, I think we had 1 here too. We multiplied 1 with 2. But now there is nothing here, and there is 10 here. The coefficient of x squared is actually 1, though we don't usually indicate the presence of 1 there when dealing with variables. The presence of 1 is unnoticed, but you should know that it's actually there. There is 1 here. This, how many x squared do you have there? Just 1. In the previous quadratic equation, we have 2 of it. But now in this quadratic equation, we have just 1x squared. You don't need to put the 1 there, right? So 10 times this 1, that's the first step, right? Multiply the last 10 with the first 10, equation of the first 10. That's like saying multiply C with A, right? Now if you multiply 10 with 1, you're going to have 10. Then the middle 10 is 7, right? We have 7x there, so we take the 7 and place there. Now you look for two numbers that when you multiply them, it's going to give you 10. And when you add up the two numbers, it will give you 7. If you can't look for these two numbers, then the quadratic equation is not factorizable. So let's see if we can take of those two numbers. Let's try 5 times 2, 10, right? Then 5 plus 2, 7, right? It must not always go right for the first try. You might try 5 and 2, it doesn't work. You try, let's say, 6 and whatever, it doesn't work. You understand? You keep trying. It's not necessary that the first try will be successful, right? But luckily for us, 5 and 2 give us 10, 5 plus 2 give us 7. So now I've got to 5 and 2, 5 and 2. We replace the middle 10 with 5 and 2. So we are going to have this x squared plus 5x plus 2 x. Are you there? See how we replace this middle term 7 with 5 and 2, right? Then plus 10 equal to 0. As you are nothing really changed, this 5 and 2, total 7x, nothing changed there. Now we have 4 terms, 1, 2, 3, 4. So we can factorize the first 2, also factorize the other 2. Alright, so let's factorize the first 2 terms, x squared and 5x. What do we have in common here and here? We have x here, we also have x here. We have 5 here, but there is no 5 here or any multiple of 5. So we can't factor out 5, but we can actually factor out x, right? So let's factor out x. If you bring out x now from x squared, you're going to be left with x in the brackets. If you bring out x from 5x, you're going to be left with 5, right? Okay, let's try opening this bracket to see if it's going to give what will happen. X times x, x squared. X times 5, 5x. So that's the factorization for these 2 terms. Now let's factorize these other 2 terms. Remember, when you're factorizing, the terms in the bracket must be the same. The terms in the bracket must be the same. Alright, if not, there's problem somewhere. So since the terms in the bracket must be the same, how about I just rewrite 5 plus x? Sorry, x plus 5. How about I rewrite it here and see what was factorized? Since I know the terms in brackets must be the same, let me see what was factorized in this 2x and 10. 2 was factored out. 2 times x, 2x, 2 times 5, 10, right? So that's as easy as that, equal to 0. Equal to 0, alright? So now the next step is this, the 2 terms outside the bracket, you enclose them in their own fair bracket. So this will be x, then plus 2, right? Then the 2 terms that are already in brackets and are similar, you just take one. This is why they will be similar, so you take one, right? That is, just take x plus 5, it's the same thing. Both equal to 0, right? Now that we've arrived at this point, we can say x plus 2 equal to 0, right? Then we can also say x plus 5 equal to 0. Now for this first portion, this first bracket here, x plus 2, we're going to have that x will be equal to negative 2. If you send this positive 2 over the equal to sign, it becomes negative, right? So the first value for x is negative 2. And let's see what the second value for x will be. X equal to negative 5. Send the positive 5 over to the other side, it becomes negative 5. So we have gotten the 2 answers, the 2 values for x in this quadratic equation. X could be negative 2, x could also be negative 5. So these are the 2 values for the second equation, the 2 values of x for the second equation. Alright, so before we proceed with the third quadratic equation, we have just few equations to go. We have just like 3 equations to go. So if you're not understanding to this point, like we have solved 2 and you're not still understanding, please pay attention as we deal with the third quadratic equation now. Alright, so the procedure is always the same. You've multiplied this last 10 here, this third 10 with this first 10. Now in this case, the last 10 is 33 and the first 10 is 3. So 33 times 3. 33 times 3. 99, right? 33 times 3, 99. Then the middle 10 is 100. You place your 100 here. Now you look for 2 numbers that when you multiply, it's going to give you 99. And when you sum them up, it's going to give you 100. So let's try and see if we can get those 2 numbers. Now if I say 25, right, 25 times 4, that's 100, right? Sorry. If I say 33 times 3, that's 99, right? But 33 plus 3, that's 36, not 100. So let me try another 2 sets of numbers. If I say 11 times 9, that's 99, right? But 11 plus 9 is 20, not 100. 11 plus 9 is 20, not 100. So this failed. Let's keep trying. Alright, so how about we try 99 times 1. I hope 99 times 1 is still 99, right? but 99 plus 1 is 100. You saw how tricky that was, right? So that's how tricky the factorization method can be. But try not to fall for the trick. Think as much as you can before you go into conclusion that this quadratic equation cannot be factorized. Alright, so 99 times 1 is 99, but 99 plus 1 is 100, right? 100. So these are the two numbers we are making use of, 99 and 1. So let's replace the middle term with these two numbers we have gotten, right? Let's replace the middle term with the two numbers we have gotten. That's 99 and 1. So I'm going to have 3x squared plus 99x plus 1x, right? Plus 33 equal to 0. Now see how I replace this middle term, which is 100x, with 99 and 1. 99x and 1x. We don't need to indicate the 1, right? It's not that usual in mathematics to indicate 1. Alright, so I've replaced the middle term now with 99 and 1, right? Now I have 4 terms, 1, 2, 3, 4. I factorize the first two terms and I factorize the other terms. Now let's see 3x squared plus 99x. What can be factorized? Now this is 3 and this is 99. In 99, I think we can factorize 3, right? So I'm factoring out 3. This is x, this is also x. So I can also factor out x, right? If I factor out 3x from 3x squared, one of the x will be left, x squared, right? But if I factor out 3x from 99x, there will be no x left, but there will be 33 left from 99, right? So 3 times 33, 99x, we have x there, right? So we have 3x, leaving x plus 33 in bracket. Now, I know that the terms in the brackets have to be the same, so I can just rewrite x plus 33. I'm just expecting everything to go alright. Right? So let me see what was factorized from this x plus 33. Positive 1. Right? 1 times x is x. 1 times 33 is 33. All equal to 0. Right? So as usual, you take the two terms outside the brackets, enclose them in their own bracket. So this will be 3x plus 1. 3x plus 1. Right? 3x plus 1. Then the two terms in brackets which are similar, you will just pick one of them and place it. X plus 33, right? Both equal to 0. Now this first bracket, we have that 3x plus 1 is equal to 0 and x plus 33 equal to 0. So this is going to be 3x equal to, if you send this positive 1 over the equal to sign, it becomes negative 1, right? For this other side, if you send positive 33 now over the equal sign, it becomes negative 33, right? So we have gotten the first value for x, which is negative 33. But to conclude on this other end, this is what we do. We divide both sides by 3. So we have that x is equal to negative 1 over 3. This is the other value for x. This is the other first value for x. This is the other value for x. You always get two values for x. We're solving the quadratic equation. Alright, so before we get going with the fourth question, I really hope you're learning something new today. I hope you're getting the knowledge I'm trying to pass across. Now, look at this fourth question, 2x squared plus 18 equal to 0. It's looking confusing, right? We're going to get back to it. But let me inform you guys that this fifth equation here, you're going to take it as your assignment, right? Factorize this fifth quadratic equation and drop the answer in the comment section below. So let's get back to this fourth equation. We have 2x squared plus 18 equal to 0. Okay, looking at this question now, I've observed an error here. This positive sign is meant to be negative. I just took the correction now, but since it's already appearing there, I'm going to solve it anyways. So we're going to have 2x squared. Then this 18 now, this positive 18, which was meant to be negative, but since it's positive, let's solve it that way. Now this positive 18, I'm going to send it over the equal to sign. It's going to become negative 18. Negative 18. Now we have 2x squared equal to negative 18. The next step to take is this. You divide both sides by 2. For x squared to be alone, right? You divide both sides by 2. So these two cancel these 2. We have x squared equal to negative 9. Since 18 divided by 2 is 9, right? Now that we arrived at this point, we use this square here to take the square root of negative 9. And this is where that problem comes in. I said this was meant to be negative. If this sign here now was negative, and I send this 18 over the equal sign, it's going to become positive 18, right? Positive 18. And positive 18 divided by 2 will be positive 9, right? And it will have an actual square root, because the square root of negative 9 now is going to give us an imaginary number, which will be 3. This is the imaginary number. The square root of positive 9, we all know is 3, right? But the square root of negative 9 is an imaginary number, because it does not really exist. Alright, so I'm going to take that correction and solve this over again, right? So assuming the sign now there was negative 18, this is what we are going to have. We're going to send the negative 18 over the equal to sign to become positive 18, right? Now that we've arrived at this point, we're going to divide both sides by 2. So the 2 can clear this 2. We are left with x squared equal to 18 divided by 2 is 9, right? 18 divided by 2, 9. So we have x squared equal to 9. Now to take a step further, this is what we do. We use this square, the square of x, to take the square root of 9. So x is going to be equal to square root of 9. And we all know the square root of 9 is 3. You know, in quadratic equation, we usually get 2 answers for x, not just one value. So whenever you're taking the square root of a number, just bear in mind that your answer is going to be positive or negative. So we're actually getting 2 values for x here, positive 3 or negative 3. For example, the square root of 4 is not just 2, it's positive 2 or negative 2, which can also write as plus or minus 2, plus or minus 3. Why? Let me explain that to you. Now, assuming we are taking the positive 2, positive 2, right? Now, positive 2 squared, that is 2 times 2, is 4, right? So the square root of 4 should be positive 2, right? Now, negative 2, let's consider the negative 2. Negative 2 squared, which is negative 2 times negative 2, is still equals to 4. It's still equal to 4, right? So whether your number is positive or negative, once you square it, it gives you a positive value. That's why when you're taking the square root of a positive number, your answer should be either positive or negative, plus or minus. That's how we arrive at plus or minus 3, right? So the values for x are positive 3 and negative 3. These are the 2 values for x when you solve this quadratic equation. Alright, so there you have it, quadratic equation factorization method dealt with. Do well to like this video, subscribe, and also comment down there in the comment section your answer to this assignment I gave. Comment your answers to this quadratic equation down there in the comment section. If you also have any suggestion on how I could improve this channel, how I could improve the way I try to pass the knowledge over, also comment your suggestion down there in the comment section. So bye till then.